We'll do questions at the end. Thanks all.
Well, I can't claim any credit for the title. That was actually one of my colleagues. We've not had a chance to use it, so I thought it was fitting to use it today, and it's quite catchy. So yeah, apologies about that. So I'll just do a quick introduction, and then I'm going to do a bit of a general overview of AI and what type of AI that we've actually applied so far at One Big Circle. Bit of an example and maybe what's next. So I'm Cate Lough. Nice to meet you all. I've worked at One Big Circle for a year and a half, and I'm in their business development team. So what qualifies me to talk about AI? Absolutely nothing, other than the fact that I now work in a company where there's lots of people doing this incredible stuff and this incredible work. And they've previously done this in other industries. And we've basically sort of cherry picked some really good people from different companies to come and do some machine learning and AI on all of this rAIl data that we're gathering. So a little bit of background about me. I studied physics before, so I guess that kind of helps. Know a little bit about coding, but just don't ask me to do any now. And then I spent 7 years working for Cate Lough rAIl in the rail industry. So I then entered One Big Circle, who are this SME technology company with no prior rail experience. A lot of the guys there, their expertise have come from different industries, so sport and highways predominantly. And now they're applying that learning and expertise to the rail environment. So there's a few of us now within the team that have got a little bit of background in rail, which just kind of helps tie it all together. So just to help with the context of what I'm going to talk about, for those of you that haven't seen AVA or automated intelligent video review, sorry, this is about the only pitchy bit in this, and then we'll move on to the AI chat. So basically what One Big Circle have done is take cameras and put them on trains. That's not new, but the difference here is that the data all gets captured automatically and transmitted automatically up into a platform that looks like this. And then these are some of the really simple tools that users can use on the data to interface. So things like annotation, searching for your location. We've managed to map all of that to Network Rail's engineering line references. You can take measurements because we use the track gauge to calibrate, and then you can take measurements within those different image frames. So that's a little bit of an overview of that and the wealth of data and why we've kind of then moved into this sort of machine learning and AI space. But apart from that, it just makes for really good watching. So if you're ever bored on a Friday night, you can do this. And it's also for a great fun game. So anyone know where this is?
Royal Albert Bridge between Plymouth and Saltash.
Exactly that. I even have the ELR line reference in case someone was going to challenge me on where it was. So yeah, but so if you haven't heard of AVA, that's what it does. So what we're here to talk about, AI. So what is AI? AI is where we get a computer and we teach it things and we get it to do stuff for us. But the point is, so instead of maybe conventional things like statistics, where we're very directive in what with the information that we want to find, with AI, the idea is that you give it something and it then starts to behave almost human-like. So examples of this in use that probably most people know about now are sort of ChatGPT. In terms of that's a large language model, so a particular type of AI that's in use there. We can also heavily used now in gaming industries, also in healthcare, finance, and obviously self-driving cars over on the right-hand side. So very big in lots of different industries across the globe. And why do we need it? So in the 21st century, we're just getting huge quantities of data, and that's all industries, including the rail, and it's just too much for us to process and do a lot with. So with things like machine learning, we can use that data and we can look for patterns and teach a computer to do that for us. And then we can use the insight that we gain from that data. So we're actually making use of the information that we have available to us. It can bring about huge cost savings and operational efficiencies with that data that we can try and find what the issues are and then what we might be able to do. And obviously the cost pressures that we have at the moment, cost of living crisis and the financial pressures, anything that we can do that can help from that point of view is great. And then also ultimately to help improve passenger journeys. So using this data to identify those issues and help solve some of them, hopefully the ultimate goal is that it improves the rail service that we are all hopefully trying to work together and provide. And I think the other thing I just want to touch on there is the skills that are potentially leaving the industry. Lots of other industries people can go and work with, and also the ageing workforce and that experience and knowledge that's leaving. So potentially with some of this AI and using their expertise to develop some of these algorithms, we've got the potential to try and keep some of that experience and knowledge within the industry. And then I thought this was quite useful. So I was at an event earlier in the week, so I can't claim that this was my idea, but I thought it also illustrated home the point that that someone actually made, that over the last 15 years, actually the train performance has pretty much dropped. It's on a downward trajectory in the UK. I'm not going to go into a variety of reasons as to why, but maybe this is a good reason that we need to look for other solutions, obviously, other than AI. The little spike there is obviously COVID. Great performance when there's no passengers and not many trains running. But obviously, yeah, a downward projection, which I don't think many people would be happy with. And then before we go into the sort of an example of the AI that we can apply in the rail industry, a bit of a health warning. So obviously don't want to start a debate on is AI good or is it bad here, because we probably get into a bit of an ethical debate and things like that. But there's things there that you really need to be aware of. So the output obviously needs to be taken with caution and scrutiny of what you're getting. Anything that you get out is only as good as the data and the algorithm that you put in. From a legal point of view, not all of the regulations have caught up with where technology is in the AI space. So it's something to then obviously be aware of. And what we have here is the AI hype, or hype curves for technology. So what normally happens is something will trigger the new technology event. We'll see this great peak of expectations of what people think this can do. And as we move over time and people sort of learn more about the visibility of the technology, you get this kind of peak expectations, and they think it's going to solve all of their problems and change everything about the world. And actually, reality is that it's probably not. It's going to help, certainly, but probably not solve all of your problems in one foul swoop. So then you end up in the trough of disillusionment, a little bit sad about the state of the world. But then you start again with sort of the slope of enlightenment, and that's where we kind of apply the technology, use it in the right way, manage expectations on what the outputs are going to be around it, and then we end up on this sort of plateau of productivity. And kind of this was discussed earlier, I was at the Light Rail conference, and someone made a point of actually how much you put in on that slope of enlightenment really does help where that plateau then ends up on productivity. So I thought that was quite good. Ones we're probably all aware of then as other sort of health warnings, ethical concerns. So I think most of us have probably seen deepfake videos. It's probably the best example. Obviously concerns there around privacy and consent and things like that. So again, coming back to the point of it's only as good as the data that we put in. So bias and discrimination, if we have that already within the data sets that we apply this to, and then also the algorithms, the results that you get out are likely to be biased and discriminatory. Military applications of this technology, obviously this technology is great, applied in the wrong way, like everything, do you get stuff like robot killers, and obviously the impact of what this is going to have on the workforce, changing in roles and things that people are supposed to be doing, and then do we become over-reliant on this type of technology so we don't actually then retain the skills. So everything to be aware of, a balanced view. So applying AI to the railway. So firstly, you need some data. So we're quite good at that, I would say, at the moment. And whether that comes from remote condition monitoring sensors, sensors on trains, sensors on platforms, even sort of taking, I know sort of telephone companies are taking data from people's mobile phones, you know, how many passengers are in a station at any one time. So I think we can all agree we've got reams and reams of data in the rail industry. And then we need to be quite clever about how we're going to handle that data. So that's a lot of stuff to either store. How long are you going to store it for? Where are you going to store it? Moving data from point A to point B is hugely expensive. So does it need to be moved from point A to point B? And if anyone looks after their AWS bill for their own company or anything like that, a little mistake and things like that and the processing that you sort of end up with means that you'll end up with a huge bill at the end of the month, just because somebody moved something from somewhere to somewhere else. So that all needs to be quite well thought out, and the infrastructure around this data that you're going to do. And then you can just simply use the data. So you don't actually necessarily need AI. I've just put an example here, and what's going to happen is someone's going to go on here and they've marked up positions of where a potential possession is. So we didn't need any AI here. Somebody's found their location on the map and then quite simply use the data. And that's great. We can do that. But for other things and with the volume of the data that we're using, that's where we need to use AI, because the time that this has taken someone to do, maybe download and everything like that, we could probably make that more efficient. Is that the most efficient use of this individual's time? And then we get to this. So we've now decided, yes, we're going to apply AI to our set of data or data sets. And what do we need to think about? So where to start? And we get this quite often with calls when you kind of explain to someone what's the capability with machine learning and what we currently have. It's, oh my God, we can do everything. And you kind of, let's walk before we can run. And what are your priorities? Because actually, as we go on here, there's lots of different things that we can tackle. Which ones are causing the most pain? So which one should we start with? Understanding the outputs. As I said already, it's not going to solve everything. It's not going to do 100% of the job that a human can do. But if it can get 70% there or 80% there, is that useful? If the answer is yes, let's go ahead. If the answer is no, might want to rethink, and maybe actually that's not a priority for something that we want to use AI for. And as I said, still need the human verification and context. So human experience, understanding of the railway, the environment that you're working in, political, social, everything like that. It's unlikely at this point in time that we're going to be able to take all of that context and put it into an algorithm. Effectively, what we're going to do is look for patterns and repeatability and point things out. So at the end, we still need someone to say, yeah, that's right, that's good. And know what to do with the output that then happens, and say, yes, we need to go and fix that immediately. This is a real problem, or actually, we don't need to worry about, we know what's causing it. Let's not worry about it. Does that one come up? Yeah. And then the cost of developing AI. Nothing's free in this world. So there's a cost associated with this. And is it worth it? Do all of those benefits that you're going to get outweigh the cost that it is going to take to do that? And then what type of AI? So the AI that I'm going to show you now is a type of machine learning, which is a bit of debate about whether or not it's a subtext, but for this definition here, we're going to go with it's an application of AI. So basically for machine learning, it's a field of AI where we teach a computer to perform a task. So we look at repeatability, teach it, train a model, and then the computer can then go on and look at data it's not been trained on and identify that. So in this instance, we're going to look at object detection. And what I'm going to do now is take you through this example of balance weights that we've done, and just use this to basically explain the steps that we would work through as we train up a model and AI. So the technical journey, we can split down into various things. So we've got the initial frame detection, then we go to observations, creating a prediction model, doing some actual measurements, comparing that, and then finally mapping our issues to, let's be honest, most people don't really care about the first 5 stages. What they really want to know is, where are my problems, and just let me know so I can go and fix them. So the frame detections. So this is a picture taken from forward-facing imagery, and what we want to be able to do in order to measure the height of the balance weight above the ground and whether or not it's going to bottom out, is we need to be able to tell you that that's an OLE stanchion and that's a balance weight in a frame of an image. So what we do is a bunch of our engineers will normally sit on a call with Network Rail. They're not railway people, so they need to understand what is an OLE stanchion and what is a balance weight. That one was quite a simple one for people to pick up. and then we basically go and draw banded boxes around a number of images. And what we typically tend to say is you need at least 500 good examples here to train a model that will be really good at detecting these objects. And what we try and aim to do is make sure that this is applicable to different types of forward-facing imagery, so that you're not kind of stuck if the image was in the top left of the cab one time, or it's on a different train the next time, and you get a sort of different angle, that it doesn't work. We want the model to be able to run on sort of all types of forward-facing data that we get. And then we train it. So once we've got those boxes drawn around and banded, this is what we do, the do and the don'ts. This is normally the rules that we'll work through with experts within the rail industry of things that need to be included or not to be included, or images that we decide that's actually, you can't use that image for whatever reason. It can't go into the model because it'll start producing erroneous results. And that's how we get a high quality, well-trained model. And then we move on to the observations. So this is where, So what we call an observation is a collection of consecutive frames which contain the same object, so the same balance weight or the same stanchion. So this is video data, so we're going past on the train. So if you break that down into a number of frames of images, we're going to see that stanchion and that balance weight a number of times. So what we've trained in the model before is it's going to pick up that stanchion and that balance weight on every single frame that it goes through. And now what we want to do is basically track it. We need a minimum of 5 frames to see that detection, is what we decided was good enough to have that confidence that we've definitely made what we call then an observation. So we can say, yes, this is a balance weight and this is a stanchion. And once we've got that, we can track it through the image. So you can see here the balance weight, and then the sort of blue lines on the left-hand side and the red lines are on the right-hand side, where we're tracking the top and the bottom of the stanchion and the balance weight as it goes through the frames. There'll be a little bit of deviation. Sometimes there might be a big sort of outlier on the sort of graph on the left-hand side. There might be a big outlier. The train might have bounced over something or a bit of a rough ride. So we'll discount those because obviously we want to try and get what we think that that position is. And then we look at our sort of prediction model. So these are this is what we need to know to basically say, is the balance weight going to bottom out or is it not going to bottom out? So once we've detected the balance weight, we need to be able to measure the distance between balance weights, because what we're really looking for is the midpoint distance between the two. So we've taken that as a measure between them. We set it as a maximum of 1 kilometre, but then we also got some data from Network Rail to confirm that our measurements, and we ground truth to make sure that these measurements were good, were accurate. And then the other thing that we needed here was temperature in order to make the prediction model. So we were able to get access to some weather station data, and we ran this predominantly in the northwest and central at the moment. So these are all the pins from the original weather stations that we got access to be able to provide us the air temperature at the time that the imagery was captured. And then we were able to do a prediction model. So based on the distance and the temperature where we thought the balance weight should be, some clever maths and stuff went on in the background, which I'm not going to run through. Please don't ask me a technical question on it, but basically allowed us to have that prediction model of where we think the balance weight should be. So is the balance weight where the model says it should be? And in order to do that, we needed to be able to measure 3 things in the image. So we're ultimately aiming for the ground to bottom measurement, but we need to know the balance weight height and the measurement from the pulley to the top. This is quite hard. This is probably the hardest thing to do, is to convert pixels to meters within an image, because we don't have a frame of reference. So in this particular project, what we've used here as our frame of reference is we knew that the balance weights on this particular route in this area were 30 centimetres. So we were able to use that distance to then calculate other distances. but this was probably the hardest bit of the whole process and project. And then we were able to put it together. So this is the as a forward-facing video is going through, and every time it sees a balance weight and a stanchion, all those calculations that I showed before in terms of where those measurements are from the pulley weight and off the floor, the length of the balance weights are being done. And as you can see here, this is what it would look like. Yeah, it's quite cool to keep watching, actually. Share this video as well if you just want to watch that on Friday night too. And then finally, a comparison. So, is it a problem or is it not a problem? That's what everybody wants to know. So basically, red and green, we all know what that means. And the white box then shows where that balance weight is sitting. Is it sitting within the red box or the green box? It's simple. And then we've got the sort of upper status, so if it's above or if it's lower, and then the severity, how much by, so we can give a measurement of how much that's by. So in this case, it's obviously lower, it's triggering, and we think the severity is 58 centimetres out. And then finally, and then what we do is we then look at this issue over a series of time. So you can see as we flick through on the images there, we've now seen this balance weight and set of stanchions a number of times, and we know it's in the same place because they don't move very often. So we call it an issue, and we can gather that data together, and then we can present it as, is this getting worse over time? Is it getting better after maybe maintenance has been done or anything like that? So in terms of grouping the stanchions together, we predominantly use GPS, but we also used anything else that was available to us. What side of the track is it? What's the bearing of the train and the direction that the camera was travelling in? Just especially if there's a balance weight on both sides of the track, the GPS is very hard. It will match them to the same ones, and obviously they're either side. So we will use the bearing on which side of the track to give us that accurate. It's on the left, it's on the right. So we're able to then group these observations into the same issue. And finally, what actually the end user wants to see is a map with pins and problems, and then an issue. So on the right hand side is what you'll see as an issue, and then the list view there will just show you all of the observations, so all of the times that it was seen, and what the severity was in the distance. And I think just worth noting since then, I don't know if it's on the next slide, actually it is, yeah, we've been able to move on and then provide a temperature of what temperature we think the balance weight will bottom out, which has been quite useful. So here's an example in Birmingham. And I just wanted to then move on to a couple of other examples. So I went through in quite a lot of detail there of what we've done with balance weights. It's quite an involved process. We do like to work quite collaboratively with the end users, the experts, to sort of understand what their problems are, understand what their challenges are, so that the output that is generated is useful and actually adds value. So a couple of other examples of where we've done stuff like this and applied sort of AI to different types of data. Thought it was useful to sort of provide a couple of other examples here. So this is a cracked IBJ. So we're able to now to detect joints within the rAIl inspection imagery. We're able to measure the joints if there's a sort of gap between them, and a condition assess them, so if there's any problems with them. And on this one in particular, there was a crack. So it was here in the black and white imagery, and it was also over on the right hand side. But we can obviously use AI on this one, but I think it's important to note that actually we found this through looking at other types of data and combining data sets. So looking at the track geometry data and noticing a dip, and then going and overlaying that onto the AI detections for have you got joints at that location, and things like that, and sort of starting to lay data sets together. And then this is the thermal sort of types of hotspot detection as well. So again, using an AI algorithm to detect hotspots, and then we've classified the hotspots into, so you don't actually want to see every hotspot that there is, because if you go through a station, people are quite hot, and we don't necessarily want to detect those. Also, the engineers down here, they were just interested in the conductor rail. We can detect hotspots on the signalling. They weren't interested in that, and they weren't interested in the rail wheels. But actually, I think what's interesting to note here is that's one set of data that might be useful for someone else. Train operating companies might want to use that data to identify problems with their trains. So it's taking one set of data and using it multiple times for different use cases and being effective with that. So in this case, hotspots identified. We've got an email alert that can get triggered, can be sent out, and they've obviously gone and investigated and found a fault with the hook switch, and we're able to rectify it. So the big question, how good is the AI? So you can verify it on site. Obviously, the problem with that is if you're getting sort of hundreds of alerts a day, do we want to go and verify all of them? At the start, maybe, because we obviously want to know how good is that algorithm. We've need to know some way of measuring it. But ultimately, we want to get to a point where we can trust what's going on and have some confidence in that, so that we know that when we're responding to something, it's definitely got a problem. And I'll touch on that a little bit later as well. So we went and checked a few of them out. So this one was causing a problem, came up as an alert. And this one, we said it had a bottom out temperature of 29 degrees. The site teams obviously went on site, measured it. They, with their calculations on site, worked out that it would be a 28 degrees bottom out temperature. So within a degree, I think it's pretty good. And obviously needed rectification work. So those were put in the pipeline to be carried out. And then AI in general, how can we measure sort of AI? So we can obviously go and site and measure if there's something like that that we're doing. But the other ways that sort of from a technical point of view that we do it, and I always get this wrong, so I'm going to read it. Precision. So this is all the detections that were made by the model, how many of them were correct. So if the model made no detections, then it wouldn't ever have been wrong, right?
Yeah.
So the rAIl then is how many of all the balance weights that are out there in the world, how many did it actually get? So say there was 100 balance weights out there, but we only detected 50, right? So we know that we've missed 50. But the problem is you don't normally know the answer to both of those questions. So it's quite hard to tell what the answer is going to be. For the balance weights, we were given a list of balance weights and their locations and things like that. So we were able to work out a precision score and a rAIl score. So precision 97.7, rAIl 89.7%, which again ties back to where we started with our kind of health warning right at the beginning, and understanding the outputs that you're likely to get from the AI. As I said, it's never going to be 100%. You're always going to need that human interaction. But actually, has this given you somewhere to start? If you were sort of banging your head against a brick wall, didn't know where your problems were, on which balance weights are going to bottom out over the summer, actually maybe this has done 80% of the work for you, and given you at least somewhere to start. So yeah, always worth bearing in mind. So conclusions so far of what we've done is there's huge volumes of data out there, particularly in the rail industry. Are we using it efficiently and effectively? I don't know. I think we're starting to with a lot of the work that we're doing, and I think there's quite a long way to go. I think AI is only going to continue to contribute, especially in the rail industry, but I think across all other technology and everything else that we do, I think AI is just going to become a bigger and bigger part of our lives. Key to remember what the priorities and what's our roadmap for using AI. Things might just sound cool, but it's maybe worth having a bit of a strategy of what we're going to do, and especially things like we tend to start with an asset identification, so object detection, like you saw with the balance weights there. Let's detect the balance weights, let's detect the stanchions first, and then what's the clever things that we can do from a condition assessment afterwards. I think what you've seen so far, you can see that AI is great. It can point us in the right direction, but it's definitely not going to fix everything. And we 100% still need that human context and that human interaction. So the phrase that we quite often use is human in the loop, as we can give you some outputs of the AI, but someone needs to ultimately look at that and decide whether or not that's good. So what's next? These are just my opinions, is all I'm going to say, as to what I think is likely to happen next. So combining data sets, I think, is probably what we're going to do, only from a One Big Circle point of view, and I think also from across the industry. We're already being asked, I know there's like U2U data that's made available. We're being asked to provide images alongside that, and also looking at sort of track geometry data again alongside that. So I think the combination and combining different types of data sets is something that's going to sort of happen more and more, especially as we get more adept at handling this vast quantity of data and extracting different things. I think we're going to be a bit more intelligent about what we do with the data that we have captured. And as I said earlier, some of the big costs will be whether or not we actually transmit that data, how long do we store it for, and what data actually goes through the AI processing pipeline, because it might not need to be everything. So some of the stuff that we can do is sort of process things on the edge, which means that on the device or the unit that's doing the sensing and the recording, actually making the decision there of do we upload that data, and that's kind of across any sort of sensor or anything like that. Hosting it there, that's fine. In terms of from a cost point of view, as soon as you transmit, that's quite a huge cost, especially if you're looking at things like imagery or video data. That's pretty massive cost associated with transmitting that. So smart decisions on does it all need to be transmitted. And then how long do we store it for? We weren't really capturing sort of good quality imagery from the rAIl environment 20 years ago. So there's now huge amounts of video data and all other types of data from the rAIl environment. How long do we store it for? At what point does it go? Obviously, it's useful to have a library and a record, but those kind of decisions on what stays, what goes, and what do we process? We probably don't need to process everything. Some things that can probably just have a survey once a year and then look at anything that's changed in that year. Some things might need to be daily, like the hotspots and things like that. And finally, using the same data but multiple algorithms. So actually, the data is captured once, it's shared with a bunch of different people who all have their own different sets of algorithms running on it. And then if you sort of take the outputs from each of those algorithms and you get kind of 5 people that, or 3 in this case, that have said, we've got a problem, actually, you've now got that higher confidence and trust level that you do actually have a problem, rather than just trusting one algorithms for all the reasons that I mentioned before. And what could that look like? So ultimately, I think people like visual things. So there's likely to be some kind of dashboard, Power BI, whatever that might be, that shows lots of this data. And I think people want to be able to jump between different sources of data quite intuitively. And that's something that I know lots of different suppliers are working on, and what we're working on with what are sort of the landing homepage of Ava and the dashboard is going to look like. No idea if I was allowed to share that, by the way, but that's what that looks like. And then finally, the last one I wanted to touch on was a kind of crazy idea. Obviously, you've got ChatGPT out there for sort of general consumption and things like that. But what about using things like large language models for the railway? So what do I mean? So basically, if you took all of the knowledge and the standards and everything like that that's written down and asked a computer to read it, and then you were able to take all of the information that's out on sort of sensors out there and trains and things like that that are passing by, and put all of that data in, and then you take all of the human context and you somehow able to add that all into the mix, and you combine all of that into what you call a large language model. And what this does is it will look for patterns and similarities, and it was able to, like ChatGPT, well, this doesn't exist, but like how ChatGPT works, is it doesn't work in a traditional way of going through every array and working line by line. What it will do is it will make links and nodes and allow you to jump between different parts. So it's able to give you a response a lot quicker than a traditional sort of algorithm might. So imagine you were able to do that with the railway. you need a very big computer as well, just to clarify, to process all of that. But ultimately get to the point that someone can ask your model a question, a bit like ChatGPT, and then you get an idea back of, yeah, you've got this problem and here's a recommendation of how to do it. Maybe, who knows? Yeah, and that's pretty much it. So thank you very much for listening.
Okay. Questions? Appearing online. We'll look at what was online. I guess the first question that Ian asked online was around the fact that half of the balance weights out there actually are sat on the other side of the stanchion, and how does the AI, how does the camera identify balance weights that are hanging the opposite side of the stanchion?
Well, if you can't see invisible data, unfortunately, you can't see it. So you wait for the if there's a train going the other way, you'll catch it on the other run. A lot of the sensors we've got out there at the moment go obviously go both ways. So yeah, if you don't get it on the run up, you'll get it on the run down. And again, you can look at it on both sides, so you don't have to be on the side that the balance weight's on.
Sense. Observation. AI is a tool. Humans use tools and control them. It shouldn't be the other way around.
Yes, agreed.
There's a warning in there. Yeah. I guess which industries are streets ahead of us? Where do you got any visibility of where one big circle or others are working in places where there's learning that we should be grabbing and using now in rail?
I think defence is probably the furthest ahead. Whether or not they're willing to share is probably a different point. The gaming industry as well, which we can take a lot from that. That's a bit more open and things. Yeah.
Question on energy consumption, actually. So machine learning is pretty energy intensive.
Yeah.
Have you looked at what? I mean, obviously, the whole point of the process is it relies on being hugely repetitive in order to prove that data. Have you looked at carbon footprint and how much what that looks like, and sort of benchmarked it against maybe alternatives or ways to streamline that? Have you had a look at that? Is that something that you're cognizant of?
Yeah, we're doing that at the moment in terms of like a comparison for if someone were to drive to site versus if we run it through sort of an algorithm. And obviously driving to site is like huge. I think it's kind of like, I don't know, 10 times more. I don't have the figures to hand. I think the other one to just sort of, you've got the cloud, but you've also got on-premise compute as well. So we use a bit of a combination of both. So we have some on-premise, not in Bristol, but some like in Wales, actually, South Wales, where a lot of the intense or high compute processing will happen there from a, like saving money, but also from a more efficient point of view. And then they're looking at things that they can do so that the cooling around things, around the computers actually comes from a sustainable source and things like that. And the University of Bristol actually is doing some pretty cool work with, I think I'm going to call it the rAIl supercomputer because we're really original down there, and we really like rAIl. But they're looking at sort of building a supercomputer which will have huge processing capability, but also that it's going to be sort of sustainable and carbon neutral. Hopefully that happens because we might want to use it.
I was going to say, yeah, for everyone listening, you said AWS earlier. That's not the magnets on the track. That was Amazon Web Services.
Yes, yeah, sorry, yeah. And there's just for, you know,
it's the main way Amazon makes its money now. It's not from
yes,
buying batteries or whatever.
And for transparency, I think there's Azure and all the other ones as well. So, you know, you don't have to just go to Amazon, but the bills are crazy and complex, and yeah, you kind of need to know what you're doing before you accidentally get a huge bill because someone moved something from there to there or ran some processing on something. So yeah.
What's the tolerance for measurement? Is it accurate enough to detect the likes of lipping and swarf, predict track circuit failures? Into millimeters or
on the black and white imagery that you saw, so the line scanning imagery, yes, that will be down to the millimeter accuracy. We can measure the gaps between on a rail joint, and we can measure that gap there. So that is sort of within a couple of millimeters. I don't know if it's 1, 2 at the minute. I'd have to check that. from the forward facing, you won't get that level of accuracy. If you take a measurement in the sort of forward facing image frame and you've calibrated it well, and you can check because you know the gauge, so you can measure that to check how well you've calibrated it. In the foreground of the frame, you'll get between 1 to 2 centimeters accuracy, which is good enough for some things, obviously not good enough for others, but that's where you kind of look at other data sets. And so that's what we're saying, combining the different data sets. Sometimes you might want LiDAR combined with that black and white imagery combined with forward facing.
Good answer. I think that covers that one. So I guess you can detect lipping on and swarf on rail joints, but only with a camera that is specifically looking at the rail head under the train, I guess.
Yeah.
The logic there. Daniel's question.
No, that is a problem. Especially when we've looked at sort of exporting some of the stuff we do internationally. Some countries are completely anti-cloud altogether for their security, so you require an on-premise solution. That just adds to the price, quite honestly. And then actually we're doing quite a lot of the UK, sorry, as a country, is doing quite a lot of work with different data. So I know the Australia and the UK have just signed a kind of data agreement, which basically means that you can't have that prohibition that all of your data must be stored in Australia if you're doing stuff. They're allowing it to sort of be shared or hosted in each other's countries.
Yes, similar to, I don't know, like previously Omnicom used to have like a left and right of the sets or an embankment to look or their sets. So something like that in AVR, are you looking up anything? Like I know we currently have front and back cameras, but are you looking anything to look the assets on the left and right, anything?
Yeah, we've got some imagery at the moment. It's on VIU2, it's called Strex, and it's now 2 cameras that look slightly up and slightly left. So if you search for VIU2, it'll be on there. That's the permanent install, and then we've got a couple of temporary boxes that I know get used out and about in Eastern, primarily for structure inspections, which is why it went up. But actually, people have found it's quite useful for lots of different other things. So they're looking at that. So yes, unfortunately, pointing directly 90 degrees as you then go past at sort of 80, 90 miles an hour, you don't always get the best from that. So that's why we've gone for the sort of angle approach.
Am I right in thinking that you've been looking at identifying wet beds?
Yes, yeah.
And is that in use yet, or is it still in trial?
Yeah, I think that's in use in it's being done on sort of like a region by region basis. But I think if you're Eastern, I think it's in for there. But I can give you a card or a contact, and you can email me afterwards. I can definitely point you in the right direction if you don't have access and you need it.
And then just your large language model thing at the end. I mean, clearly the question is, where's the next earthwork failure going to happen?
Yeah,
I mean, that's obviously what we want to ask it. And then the other thing, the little diagram with the joy of new technology and the trough of despair.
yeah.
And I think I'm going to have a play with doing that, because you've then got the failure, we now hate it, so we're going to forget it. And then you've got the new exec coming along going, I found this new technology. So you've got this, and then you've got people like, technology, joy.
Creating a complex model.
Yeah, exactly. And it's like, I think each different type is on probably a different point in the curve. So
Related to kind of Claire's question, but also you were talking about combining data sets. Absolutely, that's going to be the future. Something that I'll talk about quite a bit. You talked about temperatures in the example you gave of the weights reaching the bump stops. It can be quite tricky to access that data if it's not, even if it's open data, it might not be in the right format. So did you have challenges in accessing that temperature data easily, presumably off the Met Office or possibly from Network Rail?
No, it was from Network Rail.
It was from Network Rail, okay.
So because they already took it and put it in there, however, I don't know how Network Rail displays that data, but it was in a format that wasn't too bad. But what we've tried to do is actually, you can look at stuff in Ava and that's fine, but actually we've got to be able to share data between people. There's no point someone holding on to their data. That's not a lot of use. So I know things like stuff from Ava gets pushed into don't know if anyone uses DLI, the digital line side inspection tool, within Network Rail. But that's a Network Rail fronted tool completely, but there's AVA data sitting underneath it. It's being pushed in there.
I suppose related to that, have you done any, have you had any, have you been using any non-rail industry data, for example, Met Office temperature data? Have you been inputting any of that into, or had any requests to actually incorporate that?
We've done a bit of work with some satellite imagery,
Okay.
and stuff like that. That was an Innovate or an SBRI Innovate UK project. So we've done some work on that, and different types of satellite imagery and what you can do with that different types of data. So I know one of them is around sort of embankments, and their satellite imagery will look at any movement in an embankment over maybe some time and things like that, and plot them as different colour points and things like that. But this was from it wasn't the rail industry funded, it was the UK Space Agency, which again, loads of satellites up there, loads of data, but I don't think the data is being used to like sort of the full effect that it could have.
Yeah, we did have a presentation on it 8 months ago now,
Yeah.
actually. So I think that has found its way into G-Room. So there is some
Okay,
of that.
that's
in
good,
there.
yeah.
Some of
Probably
it.
why they did this Innovate UK sort of like session, or kind of everyone come up with their ideas of how we can use this data, because it's available and we need it to be used.
Perfect. Given the pace of change in mainstream technology, things that are commercially available, things that are available anymore, for high street, how much, where's the balance between investing in rail specific tools and actually making more use of readily available stuff that with the
100%, we go off the shelf first,
Yeah.
and that also applies to AI as well. So let's take people blurring, which is now completely in AVA. We didn't go and work up a people blurring algorithm. You're able to get access to these and then apply them to your data. So stuff like that, still a lot of work. You've got to get it in, and it's got to fit through your sort of code, and you might have to make some changes from whatever scenario that you're using. If you're using a camera that's actually moving, as opposed to a CCTV camera that's static. So I'm not going to pretend it was easy by any stretch of the imagination, because I think our machine learning and tech team probably kill me. But why go and start from scratch when you can take something that's already in use or available? And same goes with kind of camera sensing and things like that. We're not building new cameras. We're not sort of building antennas. We're using stuff that's there. And again, fitting that to trains, we don't need 4 different suppliers' cameras on the front of the train. We need one, and we just need that data to be available and sort of shared, which I think is where everything's moving to.
good stuff. Any more questions? He desperately tries to find out where that meeting was that I couldn't remember before. I'll circulate that afterwards. Okay, thanks very much for a really interesting presentation. I guess you've taken us through a basic understanding of AI in a broader sense, and talked around some of the pitfalls and some of the opportunities. Then you've given us some really useful rail specific examples. So I'm never going away thinking, right, okay, what more can I think of that we could do in the world that I work in to make better use of technology and AI in particular. So thank you very much for inspiring that thinking. So if we could thank Kate in the usual way, that'd be great. I guess a relatively modest attendance in the room, but 28 people online in the end. So
We get some claps
show
online.
online.
Good use of technology.
Absolutely, right. Reinforcing the point. So for those people that are online, I'm not going to invite you across to the York Tap if you want to join us for a drink afterwards. So for people that need to get off, and that's fine too. But we'll obviously be back for another York-based Yorkshire PWI meeting, 3rd Thursday of the month, as is the norm, in August with Mona, focusing in on streams, which is all about drainage and how Network Rail manages water, which again, we know the technology link there as well. So good stuff. Thanks all.
Thank you.
Thank you for having me.
Thank you.